Hello again, a new day, a new experiment, and as you can see, I'm the proud owner of a do-it-yourself power supply based on Hiland 30 volts to 3 amps PCB. Okay, what can I say? It's working great, it's up and running, and I was thinking about having some tests with my oscilloscope here, and of course, let's have a load here. It's not such a big load, 18 ohms, so I should have around 1 amp. Let's go to maximum voltage, and as you can see, we have 1.03 amps running, and here we have some interesting results. A kind of triangle, you know, it's like getting on and off, and we have a peak to peak of 2.7 volts, and that's a huge demand, or how can I say, it's a huge ripple. Is it ripple? I don't know. Let me go down with the voltage. Let me go to 12 volts, and obviously now I have around 500 milliamps. Okay, this is more plausible, you know, 3.6 millivolts peak to peak. So finally, what I'm trying to say, it's this PCB, this kind of schematic, it's really struggling to provide big currents. And you see, what I want to try is to have some improvements. First, I will double the diodes in the rectifier bridge, and I will double also the capacitor at the input. I will double the capacitor at the output. There is a small capacitor, electronic capacitor there, and let's see if we got any improvement. And also, I will change the sensor current resistor from 0.5 ohms at 5 watts to 0.33 on 50 watts. That's for better current, of course. Okay, let's start dismantle the case. And let me start having all this modification, the mode, let's say, and there we are. You can see it's very simple to take the parts off. The case is in excellent shape, so it's perfect for this kind of project, easy to dismantle, large enough to put all the things inside there, so it's plenty of space and place. Let me have the board unscrewed for now. Okay, I can disconnect the input from the transformer. It's much easier to work like that. First, let me plug the extra diodes with one of these connections, and we can give a try. Yes. 25 volts at the output, working normally. Wow. Obviously we got power there. 25.2, so this is perfect. Now we can have a load. 3.73 amps, much better, much better. Oh yes. Okay. As I expected, the serial resistor is not getting hot, you know, it's okay, but the diodes, they are really getting hot, so I have to find a rectifier of some sort, maybe a bridge, a higher power anyway. Okay, so I found this bridge rectifier. It's a TS15POG5G, so this can stand 15 amps without a problem. Instead of these diodes, which is supposed to have a 3 amp each of them, so 2 in parallel, we got like maybe 6 amps. This is almost double. It's almost triple. So let's take these guys out, and let me plant the rectifier. Minus will go here. Is it working anymore? Shall we give a try? There we are. So the AC is tied to the bridge rectifier. Now we have the output AC, of course, but let's take a look first. 20 volts. That's minus here and plus the other way. So we have 19.2 volts DC. Perfect. Well, the point is that to make this as solid as possible, because anyway I'm not gonna use it for high currents, you know, but at least I have to know if I need 4 amps for a longer period, you know, I can bet on that. Up there is the rectifier. There you go. The rectifier, it's at 81 degrees. The whole heatsink, it's like, alright, like 46. Any problem here? Let me see about this, guys. 91 degrees. Okay. But remember, we have 3.71 amps steady. 81 degrees. Not more, not less. That's more than enough. But I think I'm gonna have some more power to the fan, or voltage in fact. We can do that simply adjusting this potentiometer here. Let's see the numbers. Bridge rectifier went down to 77. The heatsink went to 40 degrees. I know it's looking bad, but sometimes the easy solution is the easy stuff. Perfect. Well, I'll find a piece of metal when I have the mood, but for now I think it's more than okay. Of course. $377. It's getting warm. Okay, so we start having the fan spinning already. 64 on bridge rectifier and 61 on the resistor. That's not a problem, not at all. Not more than 65 degrees there, and this is great. And 61 degrees to the resistor. Can we see the transistor here? Oh, what? 31 degrees only? Oh yes, the power transistor is behind here. I don't see any problem. Yeah, great. Okay, so now we can have a try to see about the oscilloscope and how it's behaving there. 1 amp at output. You know, the voltage it's keeping up very well. Let's have the oscilloscope on. Yeah, we still have those interesting triangle stuff, but it's far better. 2.3 volts. So it's keeping the current steady somehow. 12 volt with 500 milliamps, and we have, look there, a peak of 3.2. Okay, 7.8, but not more than 10 millivolts, and this is great. So we have a 2 millivolts per square, so we got one, let's say 1.5. Yeah, perfect. Very nice. Super. Let's increase 16 volts, no problem. 18, 20 volts, milliamps 7.80. But of course at the end of the scale, full power I may say, we still have this triangle wave, 2.18 volts. Okay, so that's it for today. You know, a really nice experiment. Now I have almost doubled the output. I have easily 4.5 amps, no problem with that. Really good cooling. I have no doubt this power supply will do a great job for the future. Let's talk a little bit about the modification I've done today to the power supply. First of all, I changed the diodes here with a powerful 15 amps rectifier bridge. That one, it's on heatsink, of course. Eventually, I changed R7, which originally it's 0.5 ohms with 5 watts. I changed that to 0.33 ohms at 15 watts, and that is on heatsink somehow. Anyway, it's in the wind, you know, it's in the fan wind. What else? I adjusted a little bit the fan temperature, I mean the limits of the temperature to come up earlier. That's it. The power transistor here, the final transistor, it's 2N3055, which will stand 150 watts, I think so. But if you consider 4 amps and let's say 20 volts at the output, we have around 80 watts, so it shouldn't be a problem for the power transistor to do that. Anyway, I'm not going to use this guy, you know, for continuous high amperages. No, not at all. But I need to be sure that in case I need, you know, some power, you know, like, let me show you. Let's say if I need to inject high current to find a short, let's see, I'm going up to 1 volt, 0.9, and let's say we have a short here, okay, then I can bet on 2.65 amps without problem, even more, look there, 5 amps for a short period of time, because we are in short now, you know, so this can be really useful, you know, high currents for a short period of time, just to inject current to a shorted board, let's say. You can hear the fan, it's already starting. Great. Somehow now the power transistor, it's exactly in short, you know. It gives, okay, you hear that? Nice, it's working great. Okay, I hope it was useful. I hope you enjoy the project. If you want to do this mods, be careful about temperature, you know, it's very important. And of course, subscribe, like, and, you know, be creative. And the most important thing, have fun. Bye bye.